All right, let's go over this real quick. Proportional relationships represent a constant rate of change. So when you look at your x values and y values and they change by the same number each time, that is known as a proportional relationship. There are two things that will be true about a graph that's proportional. The first thing is that the graph will be a linear graph, or it will be in a straight line. It will have no curves to it. And the second thing is that the graph will pass through the origin, 0, 0. And in a table, we want to check for equivalent ratios. In other words, a proportional table. The ratio of y over x will always be constant. So whenever you do y divided by x, if it is a proportional table, you will get a constant number. Over and over and over, you'll get the same number. All right, so the number of miles a white-tailed deer travels is shown in the table below. Complete the missing information and answer the question. If a white-tailed deer travels 84 miles in 3 hours, we need to figure out how many miles the deer is going to travel in 1 hour. We do that by doing our y value divided by our x value. That's the same thing as looking for the constant. You do y divided by x. So if we do that, 84 divided by 3, we're going to get 28. That shows us the deer goes 28 miles in 1 hour. Now, what if I wanted to figure out how many miles the deer can go in 9 hours?
Second round of buses is here. Students, please go outside if you're riding the second round of buses.
It's just like you never left school. Okay, so let's just keep going. Let's say you wanted to find out how many miles the deer can travel in 9 hours. You would just do 28 times 9. 28 times 9 will give us our y value. That means, and 9 is an x value. So if we do 28 times our x value, we will always get our y value. I could do 28 times 9, and I'm going to get 252. And if I were to just keep filling out this table, I could add by 28 each time, or I could do 28 times my x value, and it will give me my y value. Okay, now let's take a look at our graph. We have our x value on the bottom and our y value. Our y-axis goes vertical. We need to go ahead and fill out this graph. I know hours is represented by x, so I'm going to write hours along the bottom. And my y value says miles, so let's write miles on the side. You're going to fill out this graph the same way you would fill out the table and just count. You'd count by the same interval each time. So I'm going to start at 0 hours. The deer travels up to 9 hours. And the miles that the deer travels is 28 miles each hour. You just add 28 each time. The only reason I can write all of these numbers along...
Students, the second round of buses is here. If you're riding the regular second round of buses home, please go outside. Time to go home.
I'm not re-recording this because of that lady. So here we go. I'm going to keep adding 28 each time. So if I keep doing that, my next number will be 112 and then 140. I'm just writing the same exact numbers that I had on my table because all of these numbers go up by 28 each time. And 252 is my last one. So let's go ahead and try graphing this. I'm going to switch things up and use something fancy this time. If I wanted to graph my first point, let's see, my point over here would be 1, 28. So I have my x value and then my y value. That's how you graph these. 2, 56. And you would do that for all of these. 3, 84. 4, 112. And we just go ahead and graph these. So let's see. With the first point that I need to graph, it says 1, 28. So that means I go over to 1 on my X line, and I go up to 28, and I put a point. Now let's do the next one. Go over to 2 and up to 56. Go over to 3 and up to 84. Go over to 4 and up to 112. And you'll keep doing that until you finish putting all your points on here. Right now I notice that there's a pattern. All of my points are just going in a diagonal line, just like this. I know it's going to continue going in this diagonal line because I have a constant, which is 28. And now we just draw a line and we connect it. Draw an arrow saying this graph is going to keep going up. All right, let's go ahead and write out a verbal description. What that means is tell us what's going on in this table and this graph. Well, I know right now that the white-tailed deer travels at 28 miles in 1 hour per hour. So I'm just going to say right here, a white-tailed deer travels at 28 miles per hour. And in this box where it says proportionality, this just means tell us how you know this graph is proportional. Well, the first thing is that this graph is linear, or it has a straight line all the way through it. The second thing that tells us that this graph is proportional is that the graph passes through the origin, just like what we talked about. The origin is 0, 0. So I'm going to say it passes through the origin 0, 0. And the last thing is that our graph has a constant, which is 28. The deer travels at 28 miles per hour, and that number stays the same. Each hour, the deer travels 28 miles. All right, next slide. This slide right here, it starts out by giving us a verbal description, and we need to turn that into a graph, a table, and tell why our graph is proportional. So very first, we're going to go ahead and read this verbal description right here. It says the Student Council is selling t-shirts to raise awareness for the local animal shelter. For each t-shirt they sell, they will donate $7. Let's take a look at this table over here. I'm going to write in blue now. The left column is going to be our X and the right column is going to be our Y. The X says number of t-shirts. This is for every t-shirt sold, they will donate $7. And so on my Y column, I'm going to put money donated. If each shirt is $7 and they sell 5 shirts, I'm just going to multiply that number by 7 to get my answer for my Y value, which is 35. What this means is I'm going to do that along the entire table. I'm just going to multiply my X value by the constant, which is 7, to get my Y value. And then I'm going to go ahead and fill in this table all the way down. All right, so my answers for the next one, if I just kept going, I'd get $70, and then $105, and then $140, and then $175, $210, $245, $280, and $315. So we have our equation, we have our table, and we have the verbal description. We just need to write why this graph is proportional, but we haven't even graphed yet, so let's go ahead and do that. My X value is along the bottom, my Y value is along the top. My X value is titled number of t-shirts. So I'm just going to say number of t-shirts. Sorry, that looks so bad. And my Y value says money donated. So let's go ahead and write out money donated. Let's see, number of t-shirts. It looks like our number just counts up by 5 all the way. So I'm going to start at 0 t-shirts, and then I'm just going to count up by 5 each time. And then for money donated, it looks like that number goes up by 35 each time. So that's good. We can go ahead and put that on our graph. I'm going to say 35, 70, 105, 140, 175, and so on. So now when it's time to go ahead and graph these, I'm going to go and use my x value first and then my y value second. So I would go ahead and graph 1, 35. That's the same thing as my x value. I go over to 5, and then on my y value, I go up to 35. And I would do that for all of these. All right, so if I went and did that, let's say I'm taking a look at my first point, it would be 5, 35. So I go over to 5, up to 35. Now I'm going to go over to 10, up to 70. Over to 15, up to 105. So far I'm seeing a pattern. I know that this pattern will continue because I get a constant number on this graph. Let's talk about really quickly how we get that constant. Our constant is equal to our y value divided by x. So if I did 35 divided by 5, I would get 7. If I did 70 divided by 10, I would get 7. And this would happen all the way down the table. The reason I was choosing those numbers is because it was my y value divided by my x value. So I took my y value up here, divided by my x value, I just kept getting 7. So I know that I have a constant on this graph. That's one of the reasons that our graph is proportional, is because it has a constant. And in this case, the constant is 7. I know that because of the equation k equals y over x. The second thing that tells me that this graph is proportional is that our graph is linear, or it's a straight line. And the last thing is that our graph passes through the origin, which is 0, 0. All right, next slide. Read each scenario below. Determine if the situation is proportional or not. If it is proportional, then write an equation to represent it. Sorry, there are some misspellings on this screen right here, so just ignore them. Number 3 says a restaurant charges $10 for a medium pizza and $1 for each topping. Well, this tells me each pizza will not cost the same price because of this $1 for each topping. So this is non-proportional. Proportional means that your price that you're paying goes up by the same amount each time. And in this case, it would not work. Number 4 says a restaurant has an all-you-can-eat buffet and they charge $8.75 per person. $8.75 per person. So each person is going to cost that same price no matter how many people. That will give me my y value. So this example is proportional. Let's do number 5. A restaurant charges $1.50 for a fountain drink with free refills. So the free refills, they're free, so that really doesn't matter. The price of the drink is $1.50, and no matter how many people buy that drink, it is still going to cost $1.50, and that will give you your y value. So number 5, the answer is also proportional. Number 6, the first number 6. A restaurant has a build-your-own salad option, and it's $3.80 per pound of salad. So each pound costs $3.80, and that will give you your y value. No matter how many pounds you buy, each pound will always cost $3.80. So this example is proportional. And number 7, a vehicle travels at a rate of 65 miles per hour. The car will go 65 miles no matter how many hours they drive. So if we did 65 times x, that would give us our y value. This example is also proportional. All right, that is all for today's lesson. Thank you for watching.